Hello friends, today's question: a coil of mercury of length 10 cm is contained in the middle of horizontal tube of length 1 meter which is closed at both ends. The two equal lengths contain air at standard atmospheric pressure of 0.76 meter of mercury. The tube is now turned to vertical position. By what distance will the column of mercury be displaced? Assume temperature to be constant. So we have a tube which is initially in the horizontal position and the length of the tube is 1 meter. So let us say this is our 100 centimeter, and within the, you can say at this middle we have a mercury whose length is 10 centimeter, and other than that we have, you can say, air column on the both side of the this mercury. So let us call this as end A and this is B, and this is our first air column and this is our second air column. So total length is 100. So it is, you can see it says that equal length of containing air. So obviously this will be over 45 centimeter and this will be also 45 centimeters. And as it contains equal amount of equal length is there, so we can assume or presume that it contains air which is having a pressure P and volume V. Similarly, there is this part section 2 or section 2 of the air pocket which will be also having a pressure V and volume V. This is the initial condition, and in the final condition this tube is turned vertical and we assume that now in the vertical position we have end A at the bottom and B at the top, and the length of the mercury column is going to remain same but it will be at a different position. So let us suppose this is the length of the mercury column and its length will be about 10 centimeter, and this is end A, and here we assume that the length of the air pocket is now X. So we can say that this length pocket will be now 90 minus X, and we assume that now as the mercury column has shifted a little bit in the downward direction, so we say now the pressure is P1 and volume is V1, and here pressure is P2 and volume is V2. So this is our second section and this is our first section of the tube. Okay. So we call this as initial condition, and this we call as a final condition. So let us first of all discuss the, you can say, initial condition, all that we have drawn here. So we are given that the total length of the tube is 100 centimeter. Total length of tube is 100 centimeter, and we are given that the mercury length is 10 centimeter. Mercury length is our 10 centimeter, and it says that the air column is equal at the both ends. So you can say that we have a equal length of air column on both ends, so which we can write as 100 minus 10 divided by 2, which will be coming as 45 centimeters. And this tube, like I said, we are going to divide into two parts, part 1 and part 2. Okay, so we say we have part 1, which is towards the edge A, and we have part 2, which is towards the edge B. And initially, or from here, we can also draw that part 1 is equal to part 2. So it says that equal lengths containing air at the standard pressure. So it means the pressure at part 1 will be equal to pressure at part 2. Volume at part 1 will be equal to volume at part 2. So we can write further it that pressure in both columns, pressure in both columns, let us call that P, and that is given as 76 centimeter of mercury, and volume in both columns, volume in both columns, let us call that V, and V will be equal to A multiplied by 45, where A is the area of cross section of the tube. A is the area of cross section of tube. So this was our for initial condition. Now let us discuss the final condition. So final condition, we assume that part 1, or we can say edge A, is at the bottom, and part B, or sorry, part 2 or edge B is at the top. So we assume that part 1, or we can say edge A, is at the bottom, part 2, edge B is at the top. Now the length of the mercury is going to remain same, that is our 10 centimeter. So we see from here that length of mercury will be our 10 centimeter. Okay, and we assume that pressure in part 1 is P1, pressure in part 1 is P1, volume in part 1 will be equal to A multiplied by X, because we assume that X is the length of the air in part 1. Similarly, pressure at part 2 we say, let us suppose that P2, and volume V is our V1, and volume in part 2, let us suppose call that V2, and V2 will be equal to A multiplied by 90 minus X. Now, so this is, now we can use, you can say, Boyle's law for, in order to find out respective values. And Boyle's law we are going to use respectively for part 1. It means Boyle's law for part 1 will be equal to Boyle's law of part 1 in initial condition as well as final condition. Then the Boyle's law for part 2 will be equal to Boyle's law of part 2 in initial as well as final condition. So we can write for part 1, Boyle's law. So part 1, initial pressure is P, volume is V, and for part 1 in final condition initial volume is V1 and pressure is P1. So we can write here P V will be equal to P1 multiplied by V1, and from here we can say our P1 will be equal to PV divided by V1. We substitute respective values. So we get P1 is equal to, P is given as 76 centimeter of mercury multiplied by volume is our, the length is our 45 multiplied by the area of cross section, and V1 we just calculated is A multiplied by X. So we can substitute here A multiplied by X, and A cancel out with A. So this comes equal to as 76 multiplied by 45 divided by X centimeter of mercury. So this is for our P1, that is for part 1. Now we are going to use for part 2. Boyle's law. Once again, PV is equal to P2 multiplied by V2. So from here, P2 is equal to PV divided by V2. So we substitute respective values. We get P2 is equal to, we have here 76 centimeter of mercury, and V is our 45 multiplied by area of cross section, and V2 is A 90 minus X. Once again A and A cancels out, so this comes as 76 multiplied by 45 divided by 90 minus X centimeter of mercury. Now if we see the diagram, from diagram we can easily say, or we can say from final condition, the pressure at the bottom is sustained, or we can say pressure in part 1 will be equal to the pressure of the mercury plus pressure of the part 2. Okay, or we can simply also say the difference in pressure of part 1 or part 2 will be equal to the pressure due to this mercury. You can say that for final condition, you can write pressure bottom, which is our part 1, will be equal to pressure due to mercury plus pressure due to top, and top is our part 2. Or we can also say the difference in pressure will be equal to the pressure due to mercury. So difference in pressure is part 1 is P1 minus P2 will be equal to 10 centimeter of mercury. So we already know value formula for P1 and P2. We just calculated. This is our P1 and this is our P2. So we substitute here. We get this as 76 multiplied by 45 divided by x minus 76 multiplied by 45 divided by 90 minus x is equal to 10. Now it's a simple calculation. So we take 76 45 as common. We get this as 90 minus x minus of x divided by x multiplied by 90 minus x. This is equal to 10. So if you multiply it, we are going to get this as 3420, and we have here 90 minus 2x. This will be coming as 90x minus x square is equal to 10, and 0 cancel with this 0. So this gives us, if you multiply it, this will be coming as 30780 minus 684x is equal to 90x minus x square. Okay, so this will be giving us a quadratic equation, and we can write this quadratic equation as x square minus 774x plus 30780 is equal to 0. So if we solve it, we are going to get two values of x. First value of x will be equal to 731.95, and second value of x will be equal to 42.05. Obviously it will be in centimeter. This is also centimeter and this is also centimeter, but this value is not possible because the maximum length of the tube is only 100 centimeter. So we are going to neglect this part. So it means the value of x is 42.05 centimeter, and we say it is approximately equal to 42 centimeter. So it means we have to suppose to find out the displacement of the mercury. Okay, so we can say thus the mercury is displaced by, we have 45 was the length minus this is over 42, and this comes as 3 centimeters. Okay, so this is our final answer. We can also, you can say this division of you can say in the vertical section, it can be also done in a little bit different way also. We can assume that this mercury drops in the downward direction by x. Okay, if it drops downward by the x, so this vertical height now becomes 45 minus x, lower one, and upper one becomes 45 plus x. Okay, so we can solve this one by using this, and rest of the things will be same. Okay, only the length of this part 1 and part 2, we can take 45 minus x and 45 plus x. If we assume that mercury falls in the downward direction by x, in that case we are going to get directly value of x will be equal to 3 centimeter, approximately 3, not exactly 3. So it can be done in this way also, but anyways we get the answer, same answer in both the cases. So this completes the question. Thank you.